All right, ladies and gentlemen. So just to get settled in, we are going to start section 9.4 today. 9.4 is going to start talking about logs and exponential properties. So remember those laws of exponents that we started with in the beginning of time, right? And we had lots of root properties. As a matter of fact, it's a good time to review. Okay, so in section 1. So let's just do a complete overview. We had these properties, right? You had when we had the same base and we were multiplying two things with the same base, we would add the exponents, right? So this was the first one. The second one, which was a to the m divided by a to the n, this was the subtraction property, right? So these are all the laws of exponents that we had, and I'll label these 1, 2. Here's the third one. I think when we had an exponent raised to an exponent, that was a big one. We multiplied the two, right? Fourth one, a to the 0 power, that's 1, lovely. 5. A to the negative power, you guys love this one by now. This is the 1 over guy, 1 over a to the n. Okay, and then in chapter, I think there was 3 more, which was, oh yeah, I remember now. A times b to the n was a good one, and this is one that people always mistake to distribute addition over exponents over addition. So be careful here. B to the n, and likewise in section 1.7 we had it when it was a division 1.6 division problem that was in here. And we ended up with this. Okay, so these are all the properties we have for exponents back in section 1, chapter 1.6. Okay, in 7. I want to say 1 to 7.4, you guys got a few more. And what was the few more? You'll learn that, that if I have a fractional exponent, then that means I can take the root and then raise it to the exponent, or if you wanted to, you can have the choice of raising it to the exponent and then taking the root. But I will always tell you that making something bigger and then trying to shrink it normally is a disaster, unless it's really, really small, right? Like when we use a magnifying glass to make something bigger, when something is really tiny. So I find that this one I rarely use, this one I use quite a bit. All right, so this is section 1.7. This was the 8th one, and then we had a whole bunch surrounding the roots. Which were the ones surrounding the roots? Well, we know that, okay, well, if we have the nth root of a times b, that's the nth root of a times the nth root of b. And likewise, same thing if it was fractions. The nth root of a over b, that equals the nth root of a over the nth root of b. Okay, so these are all the ones we've known up until this point that were useful. So that dealt with roots and also dealt with exponents, and note they all tied in. Well, in this section of the book, we're going to have a few as well. And I'm going to try to draw some similarities. So in chapter 9, which is 9.2 to 9.4, okay, we knew that a to the 0 equals 1 can be converted into log form. So it'd be log, but what would the base be? Well, the a meant any base, so the base is a, right? What's the answer? The answer is 1 is written in the argument on the same level. That thing is always equal to 0. So that's where that property comes from. So this one was just a conversion of this guy. Okay, so a guy that we've already known. So we could potentially have some duplicates that transfer over, and then we can have some new ones too. So let's be conscious of it. All right. So I'm going to start off, and I'm going to add more and more to this list as we pile on. This might be a little bit of a longer video, closer to 20, 21, 22 minutes. All right, guys. So buckle in and pause when you need to take breaks, and pause the video when we have problems that are presented that you want to attempt before you see me do the explanation. You can get the most out of the video. The more trial and error you pack in to your experience, the more battle-born your skills are going to be, and that's what you really want. Okay, so here we go. All right, so let's say I had this guy. All right, and these are things all of you know how to do. So quick, fast, and in a hurry. I want you to pause the video after I write all these down, and I want you to chuck out the answers as fast as you can. Okay, log base 2 of 8, log base 2 of 5. Sorry, 5 of 125, and log base 4 of 64. Okay, I'm gonna count down, and then by all means, pause the video. I want you to attempt these 4. I want you to get some answers, and then I want you to unpause the video. All right, so pause it right now. All right, so if you pause the video, that means that you understand you got some answers here, and hopefully you told yourself that, okay, that 3 squared is 9, right? And you said that This would be equal to 3. This would be equal to 3. Why? Because 2 to the third power is 8. 5 to the third power is 25. And this one is also 3. Okay? So once again, mathematicians who find properties and rules and laws really are just really good pattern recognizers, all right? So let's do a reevaluation of what you already call common sense. Okay, so this is what they did. They said, oh, well, I can rewrite 9 as 3 to the second power. I can rewrite 8. Then we already know that 8 is 2 to the third power. And don't we know that 125, since we already did these, is 5 to the third power? And then don't we know that 64 is really 4 to the third power? Right? Because that's how we kind of figured out all these exponents. So what did they come to? They said, well, if we were to combine all of these into one major message, that is in general, if I have a log, and I want you, and in the let's call the base A, okay, and it has the same base in the argument. So there's an exponent in the argument, it has the same base, okay, of the same base, and no matter what the exponent is, all the exponents are different, right? It always gives you the exponent, 3, 3, 3, 3, 3, 3, 2, 2. Okay, so this should be equal to which one of those letters? X. Easy peasy. So what's this for? So an example of this could be something where someone asks you, well, what's log base 8 of pi to the square root of 2? Well, there's no thinking now. And this is kind of what are useful. Laws are very helpful when the things are ugly, not when they're cute. Okay, when they're cute, it's like it's like using a sledgehammer to kill an ant. You really don't want to have to do things like that. Okay, but you would know for this, you need some more firepower, and it's good to have been recognizing patterns and learning from them, not brute forcing everything, right? This gives you square root of 2. Done. Okay, and there's really minimal work at that point. Why the bases are the same, and why is this? Okay, it goes back to that fundamental process, and we'll go deeper into 1800 where we talk about logs and exponentials being inverses and hence undoing each other. So we will talk about that more in 1800 when we get there. Okay, in chapter 2 in 1800, if I remember correctly. Okay, so bottom line is this is a major property, so I'm going to add that to my list. Okay, so what does that mean? Property 12. If log base A is confronted by another property of another exponential that has the same base of A, then the bases will undo each other and give me X. Point in fact. All right, so that's that property. All right, so let's consider another one. Okay, and this one I'm not going to do as many examples for, but this is another recognizer of patterns. Okay, how about this one? Okay, well, what if logs undo exponentials? Does it work the other way? So what if in the exponent I have something like this? Okay, I'm just going to do 2 examples here because I find that people tend to observe these pretty quickly and get the pattern very quickly. All right, so we don't know how to attack these, so I'm going to do order of operations. So I'm going to start in the exponent by itself. So put your hand, okay, or forget. I'm going to try to fade this out if I can. Forget that this is here, and let's just look here. Okay, log base 4 of 16. That means, okay, look at the screen and look at my face. Don't look at the actual screen itself, okay? Log base 4 of 16, right? The base is 4, okay? And you're trying to get an answer of 16. What exponent must it be? 4 to what power is 16? 2, okay? So if that's 2, then that tells us this, that this thing that's I circled in here has to be 2, and then that base has to be 4. Right, now I just brought that base down because I shaded it out, right? So the exponent ends up being 2, and this ends up being 16. So what's the moral of the story? 4 log base 4 of 16 equals 16. So, peculiar, isn't it? Okay, so what do you guys think this guy's going to equal? Take a guess, take a wild guess. If you said 81, you're absolutely right. Now let's talk about why, okay? Well, this thing up here, when you evaluate that, gives you 4. 3 to the 4th power gives me 81, okay? And then 3 to the 4 gives me 81. So that equals 81. So what's the moral of the story here? So now to generalize this, in general, tau is chicken. So this is the next big property. So we had logs undoing exponentials. And now we're going to have that exponentials undo logs. And at this stage in the game, you guys really aren't going to be using these in the big kind of way that you will in 1800. But it's good to have some exposure to them, okay? So the base, what does this mean? So in general, just from these two examples, we can see that if I have a base and it's raised, and then in the exponent, there's a log with the same base, and there's something in the argument, I don't know what it is, you can call it what it is, okay? The base of A and the log base of A will undo each other and just give me regular old x, okay? The big facts, big facts. All right, so not that bad, people, not that bad at all, all right? So first things first, okay? First things first. These are just two basic properties that we've got. Let's go back and let's clean it up and make our chart more defined here. If I have a log and it's log base A of x, then it has to be x, okay? And again, this is in the exponent, all right? Now, again, we're going to have quite a bit more properties, so we're going to get into the nitty-gritty now. I try to make sure we understand why we need to use properties in a bigger kind of way. So it all starts, so the next stage of the game, the next list of properties you're going to get are going to come from section 9.6, all right? So we're going to start that via the next section, and then we'll go into it. We're going to add that to our list as we go on, and it's very useful in many different sections, all right, guys? All right, so what did we learn today? We learned that we had two major log properties, and that's logs undo exponentials, and just leave us with that if the bases are the same, and likewise if the bases aren't the same. Okay, so in the next piece of the next video, we'll start talking about solving log equations, and then that will get us to a place where we're going to have to circle back and look at these properties again. All right, guys, I'll see you on the next video.